Okay, so I'm going to pick up where we left off with the Tic Tac Toe code in the last video. And the main purpose of this video is to introduce some new material. So you're going to want to pay attention to this because I'm going to show you a new technique that you might find useful. Um, and I'm also going to show some how that lets us clean up the code. And I'll probably just do some other little bits of cleaning things up. So the first thing, the new material that I want to talk about is something called objects right here in the comment. So we've actually talked about objects in the sense that we've talked about these cells that we get from the DOM that would represent parts of our HTML page, ones that we create like here, or ones that we get by query selector. And those are objects and they have methods on them and properties. So they have the inner text property and they have um, the append property, which I guess we're using somewhere here. Here's append on display. So what we're going to do now is learn how to make our own objects and we're just going to learn the first part of using objects, which is how to make objects and use them to group pieces of data together that are related. So what we're going to do is I'm going to show you how to combine these two arrays that we created last time. So last time I showed you how to make two arrays, the board array, which contains the marks that are on the board that's designed to be easy to do things like check if there's a winner, and it strips away all the complexity of the HTML cells, elements, and whatnot. And then the cells array that was there, so we could get back to the cells. Once we found the coordinate that we wanted to change, we could get the cells from that array. So now I'm going to show you how you can sort of turn things inside out and have a single array where the values have both the mark just as a mark and also a reference to the cell. So the way we're going to do this is, well, first let me just show you what the syntax is. So it's pretty simple. Objects are like, they're another kind of value. I'll just make one here called obj. And whereas if it was an array, we would put stuff in square brackets and then put some values in here. And this is an array of 3 numbers. Objects are yet another use of curly braces. So this is actually an object. It is an empty object, which is not all that interesting. Objects become interesting when we give them properties. So we could make an object that has a name, and we say name, Fred, age 12, and favorite color blue or something. And so the syntax here is in between these braces, we give the name of the property with just a simple name. There's no quotes around it because it's not a string. It's actually a property name. You actually can put quotes around it, but name it like a variable and you don't have to put any quotes around it. Then a colon and then a value. So in this object, we have 3 different values. We have the string Fred, which is the name. We have a number 12, which is the age. And then we have a favorite color, which is another string. It could be anything. We could, in fact, say we have a property favorite colors, which is itself an array. And it's, let's say Fred's favorite colors are blue and purple. So now we have 2 different, or two, a 2-element array. And that's the value of the property favorite colors. And once we've defined object like this, we can now access those properties with the, in this case, the variable, which is holding a reference to that value, and then the property name. So name, in this case, we wanted to log the name Fred. In fact, we can probably see that this is working since I have my Tic Tac Toe with the console open over here, and I reload. Oops, what's going on? Yet again, I have to save this. Reload. Okay, and we see Fred come out printed from line 10 of our script. So that's this obj.name being logged, pulling Fred out. We could also say Fred age obj.age. Save that. Run it again. Fred, oops, forgot the space. Fred age 12. So Now you can see how we access the things. We can also set them. So after we log that, we can, Fred has a birthday, age, we could say age equals 13, or this is just any property. We could say, so it's like a variable. We can say age plus plus, and now copy that, log it again. So this is going to log Fred, age 12. Then we're going to increase age by 1, and you can probably imagine what's going to come out. So Fred, age 12, and then on line 12, we log Fred, age 13. So happy birthday, Fred. Okay, so that's the syntax for objects. I'm going to take this stuff out. I'll just leave, no, I won't. Okay, so I'm going to delete that. You can always rewind if you want to see it, or I'm going to give you more examples in a sec. Okay, so the idea here is we want to, I think we're going to say we're going to get rid of the cells array. And the way I'm not going to get rid of it right away, but I'm going to change board so that when I push things onto board, instead of the board just holding the mark, the board is actually going to hold an object that contains the mark. So whatever it was, we were started with an empty string and a cell, which will be the cell. So this looks a little funny. We have the word cell here. That's the name of the property. And then we have this cell is actually the variable. Um, and so you can just always write them like this. JavaScript actually gives us a little bit of what's called syntactic sugar, something that makes it just a little sweeter, a little easier to write. If we want to add a property to an object that the property name is the same as a variable name that exists, we can actually just put that in. So this is exactly the same as explicitly naming the property cell. Now, if we wanted it to have a different name um, like that, then we have to specify the property. So I think I'm going to leave it in the explicit form for now, but just so you might sometimes see that other syntax, and when you get used to it, it's actually quite convenient. Okay, so now our board contains not just a string, but it contains this object that has the mark and a reference to the cell. And so that means we now need to go find all the places that we use board. And I guess I'll go ahead and do this. We'll just simply go all the places we find the board. Obviously, we were using it for that string value. So now all those places we're going to do whatever dot mark. So board row column is getting an element out of that array, which is going to be one of these objects. And then we can get its mark property. And so now I can just search for board and find all these places. So this is going to be board dot mark. Actually, you know what? Let me not do that right now. Let's take this in slightly different steps. I want to decide where I want to put this. Um, all right, let's just go ahead and do it the simple way. Okay, so I'm going to go ahead. This is maybe a little bit tedious, but I'm basically everywhere that I'm using. Sorry, I don't need to do it all these places. That's the whole array. I'm getting ahead of myself. Okay, so I'm looking for all the places where we actually reference the elements of the board. So this is the whole board. So we're just going to pass that through. Same deal, same deal. Whole board. This is getting one row of the board. So that's still a row, now a row of objects. This is the whole board. Here's the place where we are. Now we have to decide. Since this is returning the row, which is the row of objects, I'm going to have column continue to, this is making our little line of three things. So we'll actually make it a line of the three objects, not the three marks. Diagonal is going to work the same way. So these functions all work exactly the same way. Here's the place where it matters. So let's see, a couple places it matters. So board, okay, so here's one. So this is getting the row and column out of the board, and we want to see if it's empty. So we're going to check if the mark is the empty string. And by the same token, when we change the board, Now, instead of changing board arrays and the cells arrays, we're going to set the board's mark or the board element at that row and column mark to be the mark variable here. So also note that these, this name is the name of this variable. This is the name of the property that's part of these. The fact that they're the same is just a coincidence. So it makes sense because they're naming the same thing. And then we can say board RC, get that object that has both a mark and if a cell is the other property. So that gets us access to the cell. And then we can set the inner text of that cell to equal the mark. And then means we don't need this cells array. So I think if we look, that's probably the only place that we used the cells array other than when we were building it up. So that actually means we're ready now to get rid of this whole array because the cells, so that means we don't need to make these rows and we don't need to push the cell onto the rows of that array because it doesn't exist anymore because we've instead stored the cell in this object, which is now in this the elements of the board are these objects. Um, so I think we can do what we did last time, see what's going on. Now we're going to console log the board. Some other things are not going to work exactly right because this line, remember, this used to be an array of 3 strings, and we were checking the, the strings that were in it. Now this line is coming from these functions because uh, they didn't change, but the board thing that they were pulling stuff out of changed. So I guess the simplest thing is this is another place where what we care about is the mark. We can't just compare the objects because the equals comparison of the objects will just check if they're the same object. And that was a double equals that should have been triple all along. Okay, so now we're checking if the mark is not empty and the 0th mark is the same as the 1th mark and the 0th mark is the same as the 2th mark. Um, so I think if I've done everything right, that should be working fine. Great. Um, and why did it show up quite that way? So at this top level, it looks like an empty array, but we can see that we can expand it. So this is our board that we console logged. And when we expand it, as before, it had these 3 rows. And inside each row is these objects that have a cell and a mark. And there's the actual live div. So we can see that the 0th row and the 0th column of our board array um, as a mark X and the div that gets highlighted on the screen. So that looks pretty good. Let's go back here. So what have we done? We have gotten rid of the cells array by moving everything into the object. And actually pretty minor change. We changed the places that we accessed the string before, we now have to use the mark property. And the place we changed stuff, we're going through the board in both cases. So some other things I wanted, so that's objects. And so that's may seem like a small deal. I'm going to make some changes in a little bit that's going to make some more use of objects, but at least we can see that like there's just one less thing to worry about. We just have this one array at the top level, and then with the complexity kind of getting pushed down into what's inside that array. Um, okay, so that was a pretty small change. While we're here, now that we've got the board, this is kind of more of a cleanup of something I probably should have done in the other video. But remember how I wrote a lot of these functions take the board as an argument, which isn't really needed because board is defined at the top level. So we could refer to it anywhere we wanted, like we do here in this console log. So I'll take out. And so there were just a few, maybe one, maybe actually this maybe move function doesn't take the board, it just refers to it. And it used to also refer to cells, and it would have been a pain to pass those both in. But now that there's just the one, why don't we make that also an argument? So we're just going to add another argument here, and then we're going to go to where we call it and say add past the board to maybe move. And that doesn't really change anything. But now it means that all of the references to board and all of these functions are actually referring to the argument that they get passed and not to the variable that's defined at the top level of the file. And so that actually means we can take this variable and move it inside our setup function. And as is often the case, you might ask, like, what's the point of that? What does it matter whether it's inside the function or outside of the function? The main advantage is now we know that this variable, the variable itself, can only be referenced inside this function. So we don't have to look anywhere else in this file to see if someone is using this variable. So if we wanted to rename this or change it in some way, it's really only part of this setup function. Now we are passing the value along to these other functions like maybe move and is winner, and then we're using it directly here. But all the rest of it, like we pass it to maybe move, which then does stuff with it, and is winner, we pass it, and then it passes it along to all these other functions. But they are all operating on this argument that they get passed. So it's a subtle difference that it's the same value, but we don't have to what we just don't have to, we can like look at each of these functions just locally and see, okay, this thing gets past something. Once we know what that something is, we can see what it does. And likewise for this function and this, all these functions that take it as an argument. So that's and another thing that that gives us is now we could potentially use setup function more than once to create two different boards. Maybe we'll even go ahead. Well, there's no point to do that yet. Um, but it is sort of responsible for like getting this display and creating the board and then wiring everything together. And in a second, we're going to see how we can maybe also move the move variable into the same context. So first, I want to clean up another thing, which is in the interest of having sort of more small functions, I want to take this, whatever, 5, 6 lines of code, and I'm going to cut it. And I just remember where that was at line 21. And I'm going to go make that into its own function. So I just paste the code, and now I'm going to define a new function. Check. What is this really checking? This is checking the check game over, right? Because it's checking for a winner or a tie. Um, and following the pattern, I'm going to have that function take the board. Oops. I'm going to format. And so now I have this function that takes the board so that it can pass it along to is winner, and then it directly goes and manipulates the um, document. And so now we just go back to line 21 where we took that code from in the first place, and we could put this code right here. And so that makes this look simpler, but in fact, I want to make it even a little bit more simple by realizing that it only makes sense to check for, or sorry, this should be check game over, right? Check game over. It only really makes sense to check if the game is over if we've actually made a move. So maybe move, we don't know it's going to make a move. So let's actually move this down to inside maybe move, inside this whole if, that's checking whether the square is empty and whatnot. If we get to the point where we actually make a move, then we're going to check game over. So um, that makes this function basically one line long. It just calls maybe move, passing the board in the row and the column. Um, and then maybe move, maybe makes a move. And if it does, it checks for the game over. So let's save that, run it. And this seems like it's still working or not. What happened here? It used to say when someone won, check game over. So that suggests that I actually did break something. So now you get to see how we actually debug what is going on here. So the things I changed, maybe move is calling is winner. So first off, let's just make sure we're coming here. Console log in check game over. And I didn't notice I didn't get any error in the console. So it's not like something crashed or I accessed something. So here's in check game over. Here's the board. There's the mark. There's the cell. So that seems to be coming out. And at this point, it should see three marks that are all X. And so that suggests that, are we getting to is winner? Probably. So since we know, let me see what's going on here. Here's my board. Push. Seems like it should work. Okay, so now I can basically just um, it should be finding three in a row. So now let's jump ahead to see where we are in three in a row. And I'm going to log the line. Oops, save it, run it. So we can see all the output coming out over here, but I only really care here. This is a little annoying because we got to see which one it's going to check, but we know that it's going to check the first row first. So it is in fact seeing an array of three things with mark. And I change that to get the mark, line 0 mark, line 1 dot mark. And here's the bug. I missed one place. So this last comparison was comparing the mark at line 0 to, in fact, the whole object, which was never true. So I'll bet you, as they say, dollars to donuts, that this works now. Losing my dollar. R is not defined. Oh, that's a different problem. And line 87. So I think I won that bet. I actually fixed that problem, but I left a new problem, which is when we copied this code, I made a mistake because check game over used to be, this code used to live somewhere where R and C were defined, and they're not defined anymore here. So the simplest way for right now, we're going to make this better later, but we can say, well, at the place we're calling it, we actually do know R and C. So let's pass them along. And that just means we need to add two parameters here. So now when we call check game over, we pass the R and C that maybe move um, thing used. And those are really just used so that we can find the mark. So uh, maybe even better would be to say, let's pass the board, we'll pull out the mark of the move we just made. In fact, we don't even need to do that. We can say, here's the mark, right? Check the game over on the board, given that this mark just played. So changing my plan a little bit. Now I don't need the board coordinates because I was told what the mark was, basically so that I can make this message here. So now, this time for sure, run it, win, X wins. Okay, we're back in business. So now I can go and delete that console logging. And this might actually be a place where I would, here's the changes we've made, and I've gotten rid of the cells, and I've sort of done two things. So I'm going to commit this and say, got rid of cells array and refactored check game over. And going to just stage this one change. Those other two files are unrelated. So I'm going to stage this, commit it. Yeah, sure. Um, okay, I can close that up. So, so this is a little cleaner. This function is now just calls maybe move. Maybe move is responsible for checking whether the game is over. I also kind of want to go ahead and break this out. These three lines, this might not seem like a big deal, but like these three lines are kind of doing a thing. And so I'm going to do a similar maneuver before where I cut them out, paste them over here, and I'm going to make a new function. And this one is going to be actually, let's call it place mark. It's going to take the same arguments. It takes the board, the row, and the column, and also the mark. Reformat that and come back up here and replace the place where we cut the code out. And now call this new function, board, row, column, mark. And so now this function is, we can kind of see exactly what it does. Actually, I'm going to do one more, then we'll be able to see exactly what it does. So this thing, not super complicated, but you have to kind of decode to see what's going on there. So this time I'm going to go ahead and imagine what I might call this. What that was really checking is the position of the board at the given row and column empty? So I've made up a function call. And now, as I said in the previous video, let's make our dreams come true. I'm going to define that function to take a board, a row, and a column and return that value. So as I've said many times, you might ask, what's the point? We just took like this one line of code that used to be up here and moved it down here into a function. And the advantage is that now this whole function reads pretty like close to English. So how do we maybe move? If this position is empty, figure out the mark, place the mark, and then check if the game is over. So, and then each of these functions is so short and sweet that we can look at them and see, do they do what they're supposed to do? Is empty, given the board and the row and the column? Yes, that in fact checks that the mark at that position is an empty string. So that means that cell is empty. And if later we change how something else about the values we store in the board, we can just say, what do we have to change here to have this still return true or false, telling us whether that position is empty. Likewise, place a mark, does all the stuff related to placing a mark, including incrementing the move, and then check game over does the check game over. So it's lots of little functions is, especially when you get used to it, a lot easier to understand than giant functions that are doing too much. So uh, we've got the board, not global. We've got these functions broken down nicely. 3 in a row. That seems kind of fine. So I think I mentioned I want to get rid of move, or not get rid of it, but move it so it's not a top level global variable. And so to do that, I'm going to introduce another object. So I'm going to get rid of this comment. And let's just say, let's make something to represent the whole game. So there's going to be an object. And so part of the game is the board. And so we'll oops, comma, initialize that. So that will replace this board variable. And then we're also going to say, well, the other part of the game is what move we're on. And so that will get initialized to 0. So this is now part of the setup for making a new game. And we don't need that variable anymore. Now to make this work, I obviously have to find now all the places that I'm using board and access the board from the game. And ever I'm using move, access the move from the game. So first off, in this function, we'll just go ahead and everywhere we reference board, we're going to now instead reference the board property of the game object I just made. So that's there, board, board, board. And we don't actually reference move in here. So where do we reference move? Okay, here's one more instance of board. So let's go ahead. So maybe move is actually the place indirectly. It calls place mark updates um, the move counter. And so that suggests that instead of passing the board into maybe move, we should actually pass the whole game. So it has access to both the board and what move we're on. So that makes a lot of sense. So then we come down here to maybe move and change its first argument. I'm changing the name not because it has to match, but because I don't want to call it board when it's now that I'm representing the board is just part of the game. So I'm changing the name to match, but I could call this the or the game or whatever I want. But I tend to like to keep the names matching to sort of show that this is going to be the same kind of thing as it was up here. And so now is empty. We could either pass the game into as empty, or we could just, let's say, is empty only cares about the board. And place mark is the one that needs the move as well as the board. So we're going to pass the game in there. So I'm changing the argument, which then means over here, I need to take the game, which means when I want to access the board, I get it from the game by the game or the board property. Same thing there. And then to get the move, game.move. So later on in a future video, we'll see a way to um, uh, this is kind of leading to this pattern is leading somewhere. So stay tuned for that. Um, so now maybe move passes the board to is empty, passes the game to place mark, check game over. Also needs the move. So we're going to pass it the game, pass the game there. Is winner doesn't care about the move. So we'll pass it the board that we get from the game. But we need the move here. So this is game.move. So now by passing the game in here, we can get the board and the move that we need. And not 100% sure, but pretty sure that that is everything I needed to do. Nope. Uncaught reference error. Move is not defined. So this is easy to debug because I've been messing around with the move variable. So obviously I missed a place and it looks like it's line 72. Here's line 72. Oh, right. I used the move to determine what mark is supposed to be. So that needs to be game.move. And I guess while I'm at it, I can just search for move and see are there any other places. These are all on the game. So maybe that was the only one I missed. Looks promising. All right, so that seems to still be working. What am I trying to do here? Oh, wins. Okay, so that's all still working. Um, so that would maybe even be another opportunity to I made a change, like introduce this game object and put the move inside of it. So I'm going to say introduced game object. So now when I'm looking at the history of this development, I'll be able to see like at each step what I did, commit that. Great. What is that? Okay. So now I think actually in a kind of good place to fix a misfeature or a lack of functionality. There's a problem with our game right now, which I've cleverly not demonstrated, but while it detects wins, it doesn't stop the game from continuing. And then we get these nonsense about like O wins, then X wins, or whatever. So um, when you guys were doing this, I wouldn't have let you get away with that. I would have said, no, you got to stop the game once it's over. So the nice thing is that now we have this object that represents the state of the game, what the board is, all the marks, all the cells, what move we're on. So let's just add another property that says whether the game is over. And initially, obviously, the game is not over. So we set that property to false. Um, and now we just have to think about where do we know that the game is over? Well, that's when we've made a move. And we, in fact, have a whole function called check game over. And when we find a winner or we find a tie. In both of these cases, the game is over. Otherwise, it's not. So it's as simple as, and lo and behold, this function gets the game as an argument. So we can just say game over equals true in that branch, game over equals true in that branch. And so now we're keeping track of whether the game is over. And we could, if we wanted, let's just use our old console logging technique to see game over, game dot over, and we'll just log it. So we think we're tracking, in fact, whether the game is over. Why isn't that coming out? Reload. Okay, game over is false. Game over is false. This number is going up because it's printing exactly the same message. And then we get a new message, game over true, because we in fact just set it to true after check win. So that suggests that we've done it. And so now we just want to use that information. And the place we need to move it is right here in maybe move. We have a new criteria. We can move if the square that we want to move in is empty and the game has to not be over. So I would write that as if not game over and is empty thing. So this is, again, accessing the game object that we passed in, getting its over property, which will be false if the game isn't over, and then not flips it. So if the game is not over, that'll be true. And then we check if it's empty. But if the game is over, true negated is false. The whole thing is false. We don't even have to check the square. We know that we can't move. So with that change, now after X wins, all the other moves are ignored. So that's a feature that I really should have done last time. And before we had the game object, I would have just had to make another variable at the top level that just keeps track of like the one game, is it over? So now we can do one last thing. I think this video is probably getting a little long. Um, I want to, instead of having to reload all the time, I want to have a way to reset the game. So let's pop over to our index.html and add a button called reset. And that is going to say reset. Save that. Look at our page. And so now there's a reset button, which we can click, but it doesn't do anything because we haven't said what it should do. So then we go to our back to our script. And what we want to do, obviously, when we press that button is like reset the game to its initial state. So we can, or almost its initial state. We want to leave the cells in place. And so in order to do that, I'm now going to have setup return the game object. So this setup is in fact setting up the game object, filling in the cells, filling in the initial marks, so everything moving over and returning it. So now down here, we can make now a global variable because we want to refer to it in the click handler for our new reset button. On click is going to be a function that is going to reset the, oops, reset the game. Well, we don't actually have a reset function at the moment, but that's easily remedied. We're going to write a function reset. It's going to take the game as an argument, and it's going to do everything we need to do to get back to our initial state, which is, first off, set the move to 0. Oops, having trouble typing now. Set the game over back to false. And now we just need to set all the marks and cells back to their initial, or yeah, the cell text back to the initial state. So oops, sorry, JavaScript. Um, we've written this loop a bunch of times now. We should be pretty good at it. later in the year, maybe we'll see some more convenient ways to do this, but for now, this is fine. So we're writing our regular nested loop, so we can loop through all the rows and columns of our board. And now we want to get, and to, in the interest of saving a little typing, let's call the thing that's in one of the elements of the board, we'll just call it a tile, for lack of a better term. And so we're going to get that value out. So we're going to access the array once, and now we can say tile mark equals empty string, tile cell inner text equals empty string, and that should take care of that, I think. So we set move, we set the over. So we just kind of want to compare, is that board going to be in kind of the same state as the board that came out of setup? And it seems like it would be. So no, we're not making new objects. We're just setting the properties back to what they should have been. So now if we save that and run, so we can actually set price reset anytime, and we get a type error, cannot read properties undefined, line 106. So good news. Oh, board. Some of you may have noticed board is not by itself a variable, it's part of the game. So from the game, get the board, from the board, get the row and column. Things seem to be working. Reset and fax resets, and X wins. We reset the board, but we didn't clear out the message about who won. So that seems like an easy fix. We can basically just copy one of these lines that sets that message in the first place and send it back to nothing. Come on. We'll just set it back to what it was initially. Okay, so one more time. X, O, X, O, X. X wins. We reset. Everything goes back. So again, not a huge change. I guess this one was just adding the over, returning the game. So again, I did two features. I did the like stopping the game when it's over, and now adding the reset button. So I will stage that and say game over, stop, and also, oops, reset. Okay, so not actually a ton of changes in this video, a little bit of just moving things around, breaking out some more functions. So we have even more, even smaller functions, which I would argue you get used to is quite a bit more readable. I'm going to reformat this. No, that's how the formatter wants it. And now also note, this is actually this is a sign of good code where there's basically a bunch of definitions. We're defining a bunch of functions at the top level. Nothing is actually happening other than these things, these definitions coming into existence until we get to here. And now we call our main function setup that creates and returns this game object, which we then can use to wire into our reset button, and everything else is wired together by the setup and the event handlers on the cells. So um, the code that actually runs to do stuff, I guess, is really just all just wiring everything together. And now it's just waiting for users to click and stuff. So um, there will be more on this, but you should understand this syntax, and you should start thinking about how you might want to, excuse me, how you might want to use it in your projects. So another video down the hatch, and you'll probably watch this over, well, by the time you're hearing this, you've watched the whole thing. Probably took a day or two to get through it all. All right, so until next time, enjoy.